by hand and on the CAS the inequalities y is less than negative 3 over 2x minus 4, and 2x plus 3y is greater than negative 6. So let's look at the first one first. Well, first thing we want to do is we want to change this into just a regular line and graph that. So I'm going to graph the line y equals negative 3 over 2x minus 4. Start with my y-intercept, negative 4, and then rise 3, or negative 3, run 2. Put another point in the other direction here as well. Draw my line through it. Stop and think for a second. Is this going to be a solid line or a dashed line? It's dashed because it's strictly less than that we're looking for. From there, we try the point 0, 0 and see is that in the solution region. So let's substitute that in. I'll let you try that yourself. If you're not sure how to do it, check back on the video from example 1. Once we simplify that out, we get that 0 is not less than negative 4. This is my left side and my right side. 0 is not less than negative 4. So the point 0, 0 over here is not in the solution region. So that means over here, this is my solution region that I've shaded right there. Don't forget to label it. And that's the graph of the inequality y is less than negative 3 on 2x minus 4 graphed. Show you in a sec how to do that on the CAS. On the CAS is incredibly easy. We're going to add a graphs page. And then there's a couple of different ways we can do this. We can do menu, graph entry / edit, and then 2 for relation. And in there, we're going to write the inequality, which is y less than negative 3 over 2 times x minus 4. Graph that, and you will see it does a dotted line here. We've got the same y-intercept, the same other points. The CAS hasn't labeled, but it will always have the shaded region as the required one. Let's look at part B. For part B, we want to graph 2x plus 3y is greater than negative 6. Once again, start by pretending it's an equality, a line, and graph that. So we'll do that by finding the intercepts. For the x-intercept, let y equal 0. Let you figure that out. So the x-intercept is negative 3, 0. And I've plotted that on the graph. The y-intercept, let x equal 0. And the y-intercept is 0, negative 2. Got that on the graph as well. Draw my line through. It is a dashed line once again because I have a greater than sign, not greater than or equal to. Test the point 0, 0. Let you have a go at that yourself. Does 0, 0 actually lie in the solution region? Is it a solution to this inequality here? We end up with 0 is greater than negative 6. Well, yeah, that's true. So 0, 0 is in the solution region, and all this area up here is my required solution region labeled nicely there. Show you quickly on the CAS how to do that, and that's it. Once again, we'll use a graphs page. You could have done it on the same one, but I'll use a different one. And I'll show you just another way of getting to that relation. So if you come in and you see this, you can just press backspace or delete, and then you'll see all of these options here. So you can actually directly create a linear inequality in the form y is less than or greater than here. But you can do 6 to get yourself a relation We'll type in the equation, or the inequality again, which is 2x plus 3y greater than -6. Plug it in, and once again we do have a, not sure why this isn't showing up, there it is, as a dotted line with the point 0, 0. Yeah, that's in the solution region. Off you go.